great. We're not going to go over all of these, but so that you have some of them that are correct, we'll go over 2 to 3 of them. So show me on your hand or hands which numbers you would like to go over. Show me on your hands. See a lot of 3s and 2s. If you had a 3 or a 2, put your hand down. Everyone else keep your hand up just so I can accurately measure. If you had a 3, put your hand down. 4, 2. So I saw an equal amount of 1s or 4s. So everyone put up a 1 or a 4. Fours on that. So 2 and 3 and 4. Right, 2. The 4 steps of the data cycle. Formulate questions. I wasn't expecting us to do that, and then I completely forgot what they were. So I know formulate questions. I just put these words. Collect data. Thank you. And then organize and represent the data, and then analyze. Yeah. Collect. Acquire. Organize and represent. And communicate results, but I'm not writing all that. And my handwriting is not great here. So formulate questions, collect and acquire data, organize and represent data, and analyze data for your 4 steps of your data cycle. Okay, so make sure you have all 4 of those. The rate of change is your slope. You're using your slope formula to find that. Your y2 minus y1 over x2 minus x1. So I'm going to label those. And then find that by doing -5 minus 6 over 6 minus a -5. And then simplify. -5 minus 6 would be -11. This would become a plus 6 plus 5. So we have -11 over positive 11, which would simplify to be what? -1. So the rate of change or the slope is -1. Okay, questions on that one?
Is that the number 3?
Yeah. And then in number 4, we have to describe the transformations. We started with y1 equals x, and now we're at y2 equals -1/2 x plus 3. There are 3 things that occurred. What are those 3 things? What does?
The y-intercept.
The y-intercept, and let's use our vocab words. Shifted up 3. There we go. That's one thing. Go ahead. The slope reflected because of the negative. And the last thing.
You got less steep by 1.
Yes. This what the slope got less steep by 1/2. There we go. So we need to keep all of that in our minds somewhere so we don't lose it. Make sure you have those written on your answer sheet. We're going to talk about the course calendar and possibly start this, but not do a whole lot. Yes. Because the slope here is 1/2. So because it's between 0 and 1, that fraction, that would be less speed. Okay. Look at your course calendar. Take note of the delta math. This one does not say which ones are informative and formative. Put that up there. I'm going to tell you which ones those are. 3.1a, which is multi-step equations, that one is formative. 3.4 is real-world problems. That one is also formative. Those are both due next week. The 3.1b, which is going to be multi-step variable, solving multi-step with variables on both sides, that one is informative. The 3.2, the absolute value equations, that one is formative. And then the 3.3, the literal equations, that one is informative. Now, informative does not mean we should not be doing them, because it will be on the test, and you need to be able to practice it. So please make sure you are practicing it. No. 3.1a is formative. 3.4 is formative. 3.1b is informative. Oh, it's just written twice because we're going to do it for 2 days. Okay. So keeping all that stuff in mind. This entire unit is about solving equations in different formats of that. So take note of the objective learning targets at the front of your notes, being able to solve multi-step, being able to verify. If I asked you, yes, what is a solution, what would you tell me?
Answer the problem.
Sure. So the solution is going to be some answer to a problem. Okay, we're going to probably do a couple of these, and that'll probably be all we have time for today, which is fine. We're going to determine if the following values are solutions or not. So if I solve this equation, 13x minus 7 equals 58, and I got this answer, how would I go back and check if this is a solution or not? Yes. So all the testing stuff we've been doing is going to help us a lot here. So we're going to put 5 in for x and see if we get a true statement or not. So go ahead and multiply 13 and 5. What do we get? 65 minus 7. If I subtract 7, do I get 58? Yes. So I can say this is, in fact, a true statement. This is my actual solution. Now, in number 2, we just solved the positive for 5. So number 2 should not be a solution, but we're going to do it anyway. Put that negative 5 in for x. So we get negative 65 instead, and then if I subtract negative 65 and 7, we get negative 72. And this obviously is not a true statement. So negative 72 does not equal 58. So that is not the solution. So this is a great way to check yourself when we get into solving, especially more complex things. Go back and double check your work by putting in the number and double checking to see does it work or not. All right, questions on those?
Who's that equal sign?
doesn't equal. So I drew a line
Alright.
there. It does not. Why don't you try 3 and 4? Multiplied negative, we subtracted negative 65 and 7. Did 3 work? Was this a solution?
No.
No. Did anyone need to see that one? Yes, okay. So negative 1 equals 3 times negative 2 plus 4. Negative 1 equals negative 6 plus 4. And this would give you negative 2, which does not equal. Was 4 a solution? Yes. Did anyone need to see that one? So we had negative 34 over 2 plus 5 equals negative 12. I could divide this first part to get negative 17. And then if I add these two, negative 17 plus 5, we do get negative 12. So it became a true statement. That is our solution. Questions on this? I didn't mention this earlier, so I'm mentioning it now. In this unit, there will be sections that are non-calculator. It means you'll be testing, quizzing without the calculator, and some will be calculator. This is a mixture. Some parts of it will be calculator, some parts will be non-calculator. So again, if that's too much, or work-wise, this has been too much for you, have a conversation with your counselor. Very briefly, we're going to do number 1 on the next page, and then stop. So at the top, you are given some properties of equality, which means what you do to one side, you have to do to the other side. Except for the distributive property that's not done to both sides, you just need it to make the sides equal. So in this, you're just describing what changed, what happened, what property are they using. So this is your given, your original. What changed from step 1 to step 2? Isaac, if it's easier to look at that board instead of just when you do that. Yeah, so not just the 2 times 9, but also the 2 times x. They multiplied both of these. They distributed. So they use the distributive property where we take a number outside of parentheses and multiply it to everything inside of said parentheses. Okay. Then from step 2 to step 3, what happened there? How? Adding. There we go. We added 18 to both sides. That would be your addition property of equality. I'm just going to put add POE. And then the last step, from step 3 to step 4. Okay. Division property of equality. They divided by 2 on both sides. Okay. Hold on to these notes. Hold on to your short right answer sheet. You guys can put iPads and calculators away.